Hi. In this third video about encapsulation and validation, I'll examine drawing app 1.3 under the hood by demonstrating how validation is performed in a setter and how a getter returns the value of a property. Here we see the rectangle class with its get and set height methods as implemented in the hands-on video. So the get height just returns the value of the property, and since it doesn't have a parameter nor a local variable with the name of height, the usage of just height in this method implies the instance member variable with the same name. And so writing height or this.height means the same thing, and so we can omit this prefix. Not so in the setter. Mentioning height is ambiguous. It could mean the parameter or the instance member variable. So in the assignment statements, it is imperative to make that distinction. Note the implementation of the validation. If the value received via the height parameter lies between the minimum and maximum heights, then the value of the height parameter is assigned to the height property, else we notify the client. And as explained in the previous video, printing to the console in the library class just to notify the client is bad practice. Better would be to throw an exception. But since in this video series I don't expect you to know anything about exception handling yet, and since our client is a console client, I'm going to use this approach for now. And here are the client codes. In the under the hood analysis, I'm going to demonstrate the invocation of the setHeight method, first passing an acceptable value of 100 according to the specifications. After that, a value of minus 100, which may not be accepted. And I'll end with the call to the getHeight. So let's dive under the hood with the memory layouts. First, the creation of the rectangle object as explained in early videos. So the allocation of the local variable rect1 on the stack. The new rectangle, so we create the rectangle with its 4 instance member variables of type int on the heap. Add a fictional address 1000, default values 0, and we assign the value of the address of the object to rect1. What happens when we invoke the setHeight method with a value of 100? Invoking a new method will result in the creation by the virtual machine of a new stack frame, this time for the setHeight method, which will then become the current stack frame. First of all, the instance of rect1 is used in order to initialize the value of the dis pointer, so this refers to the same object as rect1. Then passing the value of 100 to the parameter height, so height is allocated at the second position in local variables array and will get the value of 100. Then statements will be executed in the methods. First, we allocate 2 local variables, min height and max height. They are added as well to the local variables array. Then the actual validation statement. And the only variables we'll use are those of the current stack frame. So if height is this one, 100, is greater than or equal to min height, 10, that is true. And the height, so the same 100, is less than the max height, 500, which is true, then are we going to perform the assignment. Height, the local variable, will be assigned to this.height. This, with the dot we dereference the reference variable, so we arrive, so to speak, at the object on the heap. We want to assign something to the height property, so what we get is that the value of 100 local variable is copied to the instance member variable of the object. The else is not executed. That's it for the setHeight. We return to the main method and we see that the result of rect1 setHeight with a value of 100 results in the state being changed. What happens if we pass a value of minus 100, which should not be accepted by the validation implementation? So, same process. The setHeight invocation will have the runtime to jump to the setHeight method. For the setHeight method, the current stack frame will be constructed. First initializing the dis pointer with the rect1 value, then passing the value of minus 100 to the height parameter. So exactly the same as before, the only difference is that now we have minus 100. allocating 2 more variables in the local variables array for minus height 10, maximum height 500. It is exactly the same method. So the if will now result in a false. And this time we print the notification in the console. So rectangle, invalid height minus 100, followed by the range of acceptable values. So no change of state will happen now. That's it for the set heights, and we return back to the main methods. No change of states, which is good, so our set heights behaves correctly. Finally, the get heights. Here the purpose is to assign the result of the invocation to local variable heights. We are in the main methods, so this local variable will be allocated in the current stack frame of the main. After that, the invocation of the get heights. Again, invoking a method creates a new stack frame, this time for the get height methods. We initialize the dis pointer. No parameters, so that's it. And we execute only one statement, return. So an additional field in the local variables will be reserved for the return value, which will be this.height. So this dots, we follow the arrow, and what field do we want? The height field is this one. So this value of 100 will be returned by the method. So it will be temporarily stored in the return value fields, after which we return from the methods explicitly. So we're back in the main. Last thing we need to perform though is the assignment of the return value 100 to the height local variable. Once that is done, current stack frame destroyed, and we're back in the main. That for the dive under the hood of the getter and setter. Thank you for watching. Bye.